All right, I stopped the last video just a little bit too short. What I did want to show you with that Desmos is that you're always going to have increasing exponentials here when your base is greater than 1. And so that's what I was showing you here, that when this base is some value that's greater than 1, and it's not greater than or equal to 1 because it cannot equal 1. But when it is greater than 1, all of these are going to have the same characteristic of increasing. Okay. So now let's go through example 5, where we graph y equals 2 to the negative x. Now, almost identical. Here we have 2 to the positive x. Here, now it's 2 to the negative x. When we have exponentials, and not always the case, but your homework's going to ask you for your base. And specifically, when you're giving what the base is, that exponent has to be positive. So we talked about this at the beginning of this lesson, our exponential rules here. I can rewrite this as y equals 1/2 to the positive x power. I'm taking that 2 and putting it down to the numerator, and it changes that exponent from negative to positive. Okay, so let's graph this, and then let's see, or let's answer the question. So I'm going to exit out of this one. And what I probably would do if this was mine is just simply change this to negative x, change that to negative x, and you can get all the same information. But to kind of show you again, because you do need to know how to make a table and get your table of values. Let me do this from scratch real quick. So I'm going to do y equals 2 to the negative x power. Once I type that in, I can see that. So really and truly, I can go ahead and say that this is now decreasing. Okay, and now I want my table of values. So in line 2, I'm going to hit the plus sign to add an item. We're going to add a table. And here's where the mistakes happen. I'm not answering this question specifically if you're on my on-campus class, right? Once I have this, I'm leaving x1 alone. And now in place of this y1, I'm going to replace y with what y equals. Y equals 2 to the negative x power. And then you're going to get a caution sign. You have too many variables. Try defining what x is. Here I'm showing that this column is x1, but then I'm just calling it x here. So I'm going to go to the right side of that and just type in a 1, and it automatically makes that a subscript. And now those variables match each other. Okay, now look at your graph to make it a good decision on where to start these x values. I know I don't want anything bigger than 10 because that's as big as my y value goes on my graph that I'm given. So this is starting right here at -3 and some change. So if I start here with -4, then that one's going to be the one that's too big. So now if I go to -3, then that one fits on my graph. So now it's going to just kind of guess. If I just hit enter, it guesses what the next ones are going to be. And then that one's probably too small. So I'm going to go -3 to 2 here. And let me switch these. Sorry, it's a little bit of a mess. Okay. So making my table. We have -3 and 8, -2 and 4, -1 and 2, 0, 1, -1.5, and -2 and 1/4. That's what 0.5 is and 0.25 is. Okay, so I'm going to plot those. Before I connect them, we're going to talk about this asymptote before we connect. So plot those points. Okay. And now we need to talk about where that asymptote is. If I keep going along this X, you can see that those numbers are getting closer and closer to 0, but they are never actually going to touch it, right? So we have the same horizontal asymptote. At y equals 0. So I'm going to draw that in. I'm going to go a little below it just so it'll show up, but it is on the x-axis. And now I will connect my points where I do not cross that x-axis. So this will stay above my x-axis here, and then connect those. There is my graph. So I'm kind of done with this in Desmos now. I'm just going to make this one big. What is the domain and range? Well, as I go from left to right, the domain is going from arrow to arrow. So that is negative infinity, positive infinity. And again, every exponential will have a domain of all real numbers. The range is going to change depending on where that asymptote is. As I go from the bottom to the top, the first thing I have is that asymptote at y equals 0. Asymptotes will always get parentheses because it's not going to touch it. So it does mean it's not included. And then it's going to go up forever to infinity. I again have no or none x-intercepts because I have that horizontal asymptote. It's never going to touch. And that y-intercept is at 0, 1 again. Okay, so let's kind of look at our different graphs here that I have ready for us. Okay, again, when you're in Moodle, we're in section 5.3. I'm now going to this one here. And this 2 to the negative x, which is the same as 1/2 to the positive x, is the one we just graphed. Okay, and for the record, because again, that base is 1/2, that's what's happening to all of my numbers. What's half of 8? It's 4, half is 2, half is 1, half and half, right? So everything's getting cut in half because that's what that base is doing. So now when I have 1/3, that's going to decrease even faster because now everything is getting divided by 2. It's getting divided by 3. When I divide everything by 4, it's going to decrease even quicker. And then 1/5, 1/6, and 1/7. So they have the same characteristics of that 0 to 1 and that same horizontal asymptote at y equals 0. And one more time, your base cannot be 1 because no matter how many times you multiply 1 by itself, it's always going to be 1. So they have the same characteristics as those increasing of the same, what's that called? Y-intercept and that same horizontal asymptote there. And so, this is always going to be decreasing when my base is between 0 and 1. So when my base is between 0 and 1, and that base, to determine that base, that exponent has to be positive. It will always be decreasing. Now, what I always do think is kind of interesting is that these have the exact same information except for the increasing versus decreasing, but they have the same asymptote, the same domain, the same range, same x and y intercept. So kind of crazy because they look completely different.